So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now this week we're talking about safety, specifically battery storage system safety. And by the way, I'm going to digress here. My biggest safety concern about all solar and backup power energy storage systems as a contractor is not necessarily with the solar panels or the batteries, but it's with fall protection. It's an OSHA regulation that all workers be secured with roof anchors and proper harnesses if they're in a high area over 6 feet. So make sure your solar contractor installs roof anchors during your installation so the guys or gals on your roof are working safely. But I digress. Today, we're talking only about batteries. Okay, batteries. I just look around. There's batteries everywhere. We started off with batteries in our flashlights and things like that. We got batteries in our car. Then we have laptop computers with batteries. Now telephones with batteries. Cars are powered by batteries. And now the next generation's backup power for our homes. Backup power is provided by batteries. And these are new technology batteries. So why is backup power so related and important to solar? Well, obviously, if you want lights and power at night, you got to have a source for that. And that has historically been batteries. So all solar systems before this thing called net metering, it's a utility regulation, before net metering had lead acid batteries. So you generated solar power during the day, and whatever you didn't use, you stored in batteries. And then at night, when the sun was down, you had batteries and that generated power for your home, your car, your trailer, whatever. Now, net metering is basically an accounting mechanism where the utilities will keep track of how much power you're buying. They always do that because that's what happens with an electric meter. But they also keep track of the power that you send back, and they give you the retail credit for power that you send back to them. At least that's the way it used to be. And they're kind of chipping away for that. But it's still there and it's still valid. So the question is, why do we need batteries when we have net metering? Well, first, the utilities are diluting the benefits of net metering. They don't give you the full retail rate anymore. They lobby really heavily to give you the retail rate less a few pennies. Not that big a difference. It was only like 5% or so. Now they're changing the electric rate so that the peak times of power are in the late afternoons and evenings. That makes a little bit of sense because now the utilities have so much solar power during the day that power is relatively cheap in the middle of the day. But power is more expensive in the afternoon and evenings. So when you're running your electric meter backwards in the middle of the day now, which everybody used to do, you don't get as big an incentive. Well, the reality is I look at the amount of money we get paid back now, even during the day, it's way more than it was 20 years ago. So the solar paybacks are still really, really good. But overall, electric rates keep going up. They don't go up in a straight line, but they bounce around. But the general trend, heck, I've been doing this for over 20 years, and I see the numbers going back for 50. The electric rates keep going up. And the second reason why we need batteries is because it's to provide power during an emergency, during a blackout. Increasingly useful because, first of all, there's more blackouts. I mean, heck, I had 5 over the last 15 months. And second, we're more dependent than ever on electricity. Everything we use is powered by electricity, and that's not the way it was even 25 years ago. So when the power's out, we can't use our phones, we don't have any lights, we can't make a fire in the fireplace because that's now powered by gas and electricity. Sometimes we can't drive our cars, we can't heat our hot water. It's just, we can't even cook because so many people have electric stoves. Electricity is really important. But here's the thing, and this is the topic of today's show. There's safety issues with batteries, and just 4 of the ones that kind of come to mind immediately. And the biggest one is the potential of a fire. And the reason why we're so concerned about this is because cell phones have been, burning every once in a while. And the second, got to be careful about the way in which you transport these batteries. The third, the installation of the batteries is kind of tricky. It's a heavy piece of equipment. So there's some care that has to be taken by a contractor. And fourth, there's always the potential for any kind of electrical equipment to have some kind of shorts. And we're going to talk about the way that these issues are kind of remediated. But, kind of taking a step back, why are there safety issues at all with batteries? Well, it all has to do with something called energy density. How much energy, how much power is in these compact little devices, in these little batteries, or in anything we're using. Well, I just kind of looked at some numbers and kind of went through this on some engineering websites. So we looked at the energy density of an alkaline battery, and it's about 0.14 kilowatt hours per kilogram. So a kilowatt hour is 1 kilowatt delivered over 1 hour. So that's, these batteries have a ton, a kilogram of alkaline batteries is only going to put out 140 watts for an hour, then it's dead. So the reality is these little batteries that we have in our flashlights, the D cells or the AA cells, way much less than a kilogram. If you short those things out, you're not going to create a really big problem. Maybe the wire is going to get a little hot, but it's not going to burst into flames. This is where lithium ion is different. Lithium ion batteries have an energy density of 0.5 kilowatt hours per kilogram, 500 watts per kilogram. And basically, you don't want to short one of those things out because they're really going to dump out a lot of energy pretty fast. Now, you kind of say, well, how much energy and how big are these batteries? I'll give you an example. The Tesla 85 kilowatt hour battery, that's the battery that goes in the Model S standard car, weighs about 1,200 pounds. Heck, the battery in my Chevy Volt at 16.5 kilowatt hours, the thing probably only weighs about 300 pounds, but still kind of a pretty heavy weight sitting, underneath the back seat. That's a reasonable amount of energy, 85 kilowatt hours, but it's pretty heavy. Oh, all right. That's kind of cool. Well, how does that compare to other things? Well, I looked at the energy density of gasoline. Gasoline is a great fuel for vehicles because it has such high energy density. The energy density of gasoline is 13 kilowatt hours per kilogram. It's like 26 times more than a lithium-ion battery. That's why it's such a great fuel for vehicles. 20 gallons in your tank is going to weigh about 130 pounds. That's going to put out 744 kilowatt hours, way more energy than that Tesla battery at like a tenth of the weight. Okay, so that's why gasoline is such a great fuel. But then again, that's why gasoline is so dangerous. Any kind of petrochemical is kind of like that, whether it's diesel or compressed natural gas or even the butane that's in your little butane lighter. It's got a lot of energy density in there. Now, what's better than gasoline? Well, let's kind of go to the end of the table here. Yeah, there's uranium. Uranium has an energy density of 23 million kilowatt hours per kilogram. Okay, so we're not going to go with uranium to power our car anytime soon. Gasoline's been what we're using, but lithium ion is becoming very, very popular. And I have to say that when you kind of compare the difference between energy density of lithium versus gasoline, with gasoline, you have the weight of the engine and all the other parts, and that's much heavier than with a battery vehicle because you just have the lithium ion battery and you have a couple of small electric motors. They're not that big. So when it comes to this kind of technology also, batteries are rechargeable. Gasoline, that's not rechargeable. Uranium, not rechargeable. But batteries are rechargeable. And that's why lithium ion's been so popular, because it's rechargeable and it has a high energy density. Now, some good news about battery system safety. No fire safety issues that I'm aware of at all that relate to home or building energy systems. But you have to take extra care for certain types of buildings. There's two ways that we ensure safety of these systems. First, we make sure the systems are properly designed and tested. More on that later. Second, we make sure that the contractors that install these systems are properly trained and tested. In California, solar contractors, C46 contractors, and electrical contractors are qualified to install battery storage systems. At Cinnamon Energy System, as a license holder, I've taken both the C10 electrician test and the C46 contractors test, and somehow I passed both of those. But it's important that all solar contractors have to pass the test that includes battery storage systems. And every contractor that does solar knows how to install battery storage systems because they had to pass a test, whereas batteries aren't on the standard electrician test. So when I kind of look at it, both contractor classifications are really good. The difference is that solar contractors had to pass a test to install battery systems, and electricians didn't necessarily have to pass that test. But they both do good work, and you want to find a contractor that you trust. Now, let's talk about the three different kinds of battery systems that are being used with solar. And they're different sizes and different safety characteristics. The first are large-scale commercial and utility-scale systems. These things are delivered on semi-trailers. They're in big containers. They're assembled and configured on the site. And there's safety certifications on the individual components, generally not on the entire system. So good companies that are installing these systems are like STEM, Green Charge, which is now now NG and Advanced Microgrids. Now, second are smaller commercial and residential systems. Now, some of these are also modular. Some of the early ones, they're assembled on site. You get a cabinet, you put the batteries inside the cabinet. Maybe there's like 4 sets of batteries. Then they're wired up, and then there's maybe pre-installed an inverter and a battery management system and things like that. So the safety certifications are done on the components, not necessarily the entire system. Examples of these smaller commercial and residential systems are Sonnen, Sharp Electronics, Iguana, Pika, and Adera. Good systems. They're kind of built and packaged together, not UL certified as an entire system generally. The third, and this is what's really taking off, are smaller commercial and residential package systems that are completely assembled and tested at the manufacturer's factory. The batteries, the battery management system, the safety equipment, the enclosure, and even sometimes the inverter are all pre-assembled in an enclosure that's all tested together. So the safety certification comes on the entire system. And this is very important because these systems generally have no live wires that you can touch or terminals on the battery that you can touch. There's safe disconnects and circuit breakers. Examples of this kind of system are the Enphase AC battery, the Tesla Powerwall, and the storage system with LG Chem batteries. Let's talk about the different battery chemistries. There's just a few that are really popular. We've got lead acid, which is a liquid electrolyte. That's the liquid inside. And that electrolyte's basically sulfuric acid. The energy stored in depositions that are done on the lead electrodes in the battery. And these are lead, very heavy. So you're not going to carry it around in your pockets. Although my very first Discman from Sony, portable CD player, had a pancake lead acid battery. It wasn't really that portable. All right. Now, the next big generation, although there was nickel metal hybrid in between, but the one that's really popular now are various lithium battery chemistries. So this is using a gel electrolyte. It is semi-fluid, and the energy is stored in the electrodes, as with lead acid batteries. These are cylindrical cells, kind of looking like regular batteries, but also pancake cells for consumer electronics. If you look inside your phone or your computer, they had this pancake lithium-ion battery. The newest technology, which is kind of cool, is something called flow batteries. And this is where you have a pure liquid electrolyte, kind of like an acid, but the energy is stored in ions in the electrolyte, not in the electrodes. So it's inherently safer. You don't have all this lithium ion thing that could short out and create a fire. If there would be a short, the electrolyte's just going to kind of disappear, and then the energy is going to go away. So not really that bad a problem. So very, very cool new technology, and we're kind of looking at it very closely. So with these technologies in mind, what are some of the fire safety issues for solar and storage? Well, the PV industry, the solar industry, evolved relatively slowly. Very, very few fires that I'm aware of at all. One fire issue that I remember, there were bad junction boxes on solar panels from BP Solar. And there was a building in Germany where these junction boxes kind of heated up, melted, and caused the wood roof building to kind of burn down. We've had some of these bad panels here, and to my knowledge, they've almost all been replaced. But when you looked at some of these things, and it was a sunny day, and you turn the panels on, the junction box would kind of smoke a little bit. Obviously not good. Turn that thing off. All right. Now, there have been several problems with wiring short circuits on large commercial flat roof installations. Now, the thing to keep in mind is when you have a lot of solar panels all connected in series, you might have 600 volts, and as long as the sun's shining, that 600 volts is going to be there at a very high current level. What happened on a solar array on a Target building in Bakersfield on this big flat roof is there were long runs of conduit, and in the heat and cold, this conduit would expand and contract. And what ended up happening is where it contracted one day or one night, the joints between the conduit opened up, and one piece of conduit broke away from the other piece of conduit, just hung together by all the wires inside. Not a problem at night, but when the sun came up, those wires shorted out against the metal conduit, and they started burning, and they just weren't able to put it out until basically all the panels burned and the roof burned. So that was a big problem. Now, really good news. All new inverters have arc fault protection and voltage disconnects, high voltage disconnects. So that kind of incident isn't going to happen anymore with any kind of new equipment. And that's one of the great things about the PV industry. But the battery systems are really new. There's lots of tiny little companies and medium-sized companies that are coming out with batteries, battery technology, making factories. And there's several really big companies that are also starting to flood the market with their batteries. Now, the dilemma is some of the smaller companies or the companies that really don't care that much about safety, or the companies that may consider different safety requirements applying to their system, systems, they may not have the resources to thoroughly test these systems. And the reality is most companies want to develop a product and want to get that product to the market ASAP so they can start generating revenue. So in my humble opinion, some manufacturers are rushing to the market too fast without a lot of testing that's needed. On the other hand, there are a number of big manufacturers that are doing an absolute outstanding job of developing battery storage systems, and I'm 100% comfortable with their safety records. All right, so here's the dilemma. The higher energy densities of lithium batteries can create a hazard if they're not well designed, well packaged, and well tested. So, yeah, of course, there's been fires with lithium batteries. We've seen pictures of some cell phones just burning up. Airlines, for a while, were banning certain cell phones. I think it was from Samsung. And they also recalled all these cell phones. Electric scooters, a few holiday seasons ago, manufacturers had to recall these electric scooters because the batteries were not really packaged well or not designed safely, or there was something else in there. While they're charging up, they would kind of burn underneath the Christmas tree. It's kind of a bad thing. Batteries, the lithium-ion batteries powering certain electronic systems, these were on planes. These are part of the systems on planes, also had problems. And many types and sizes of lithium-ion batteries have been banned or severely restricted, even in the luggage on the plane. So the industry is kind of aware that these systems can be problems. And you got to be careful about it. There's limitations on the way in which batteries can be shipped. You can't ship by air any lithium-ion battery system that weighs over 35 kilograms. It's got to go in a special cargo aircraft, or it's got to go by ship. So these are very sensible restrictions. So how do we keep everyone as safe as possible with this new battery technology that really is going to become pretty popular? Well, we have really good processes for testing here in the United States and worldwide. So all lithium-ion batteries in the U.S. must be tested to UL standards. Actually, not just batteries, basically anything that's dangerous, anything that's electrical or thermal, or even, basically water. So there's a couple of standards that are specifically applying to the battery storage systems that solar and battery contractors are installing. The first is UL 1973. This is an earlier standard, and this applies to battery systems in stationary applications like a building, like a house, and it really addresses what goes on with the battery components, not talking about the whole system. The newest standard is something called Energy Storage Systems and Equipment, UL 9440. So this is a standard that applies to the entire equipment. The device has to be tested together. It's the enclosure, it's the battery management system, it's the batteries, it's the connectors. I really like that kind of a test, and that's becoming standardized. Now, we're talking about lithium ion because it has the highest energy density. Other types of batteries, not as dangerous. Lead acid batteries, pretty darn safe. Although anyone who's done work on car batteries probably has holes in their genes. And I think back to 15 years, one of my employees had a custom-built electric Honda Civic. It burned to the ground about 15 years ago. This thing didn't have a gas motor. It was swapped out with an electric motor and batteries. When she turned on the defroster one cold day, there was a short, and the thing just didn't turn off. But it was safe. It didn't explode. It didn't, it was slowed down, just pull it over and go. It wasn't a massive fire. Although you've seen some of these massive fires that can happen from big lithium-ion batteries. The fires that you kind of see online on YouTube, these happen during testing procedures, and it's really good that we do those tests. If you completely short out the terminals on some of these systems and you don't have the right fuse protection, these things are really going to burn fast. Flow batteries. I really like the concept of flow batteries. Much, much less likely to have fire problems because the electrolyte doesn't burn and the electrodes won't burn. The downside is that they're just bigger. If you want more capacity, you need more electrolyte. If you want more power, energy delivered quickly, you need more electrodes or bigger electrodes. But nice technology because it's inherently safer. So the fire safety concerns I have and many other contractors and many fire safety professionals have related to lithium-ion systems are about fires that happen in buildings, multifamily buildings. The fire department in New York has very strict requirements for lithium-ion batteries in buildings, and other fire safety organizations are working on their requirements. Not as concerned about issues related to one or two family homes. These things may be installed outside the house or in the garage, and I tell you, when I look at how the batteries that we're installing are packaged, I can't conceive of how they would burn. All right, other issues with lithium-ion batteries, transportation. They need a hazmat certificate, and they have to be shipped not fully charged with less than a 30% state of charge. There's weight limits that are required for shipping batteries on aircraft. They're heavy to lift. And, you got to watch out for the shorts that happen. But I really like the way some of these package systems are designed because there's just no accessible terminals. So kind of in summary, I predict that all rooftop solar systems are going to include battery storage. Big benefits. You've got backup power, you've got energy arbitrage, you can reduce your demand charges, and you can provide grid services. There's several of the home products that are already on the market from big companies like LG Chem, Tesla, and Enphase and SolarEdge are really working well. These things are well tested, they're designed for use inside homes, and they're going to save you money and provide reliable backup power. But it's very important that the solar and the battery industry continue their efforts towards making sure we've got good safety practices and good equipment. We have to take extra care for installing these systems in certain building types where there might be a fire in an enclosed space. The systems have to be tested and certified. They have to have safety switches and disconnects so that there's no live terminals that are easily accessible. And most importantly, the companies that install these systems, the contractors, have to be properly trained and properly tested. Okay, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can always go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.